Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz Dart, and in case you have forgotten, I am the IT Geek. Welcome back to the AZ700 series, and this is part 3 of the inter VNet connectivity topic, and so we're going to be drawing it to a close, this topic, and there'll be one more video before we finish module 2. So yeah, it's been so far really interesting, and I've had some really good feedback from people in the community, so thank you very much. As normal, I'll be doing some theory, and I'll hand over to Mohammed Sajid, my good friend Mohammed Sajid, who will be then doing a lab. And I think today's lab is going to be around implementing a NAT gateway, if I'm not mistaken, so that'll be really interesting. So without further ado, let's get started with this episode. So as I mentioned, we're still on designing and implementing core network infrastructure, which is module 2, and we are on part 3 of designing and implementing cross VNet connectivity. Today we are going to focus on designing and implementing an Azure root server. We'll then talk about identifying appropriate use cases for a virtual NAT gateway. Finally, we'll look at implementing a NAT gateway, but that's where I'm going to kind of hand over to Saj rather than me talking about it. You're going to see Saj actually do it. Hopefully that'll be a lot more insightful than me rambling on about it. So let's hit that first topic, which is designing and implementing Azure root server. So with an Azure root server, it simplifies dynamic routing between your network virtual appliance, NVA, and your virtual network. And it allows you to exchange routing information directly through the BGP protocol between an NVA that supports the BGP routing protocol and the Azure Software Defined Network, or SDN, in the Azure Virtual Network without the need to manually configure or maintain route tables. And it's a fully managed service as well, so that Azure root server is fully managed service and it's configured with high availability. So big fan of the sort of fully managed services that Azure do, because there's a lot less responsibility on us as the end consumer. So just sticking with this topic for a minute, let's look at some key benefits of this Azure root server. So as I mentioned, it simplifies configuration, management, and deployment of your network virtual appliance into your virtual network. You no longer need to manually update the routing table on your NVA whenever your sort of virtual network addresses are updated. You no longer need to use user-defined routes manually whenever your NVA announces new routes or withdraws old ones. Again, very, very automated. A lot of, takes away a lot of manual sort of changes. So far, so good. A lot of good benefits. You can peer multiple instances of your NVA with Azure root server. So you can configure the BGP attributes in your NVA, and depending on your design, for example, an active-active for performance or active-passive for resiliency, you can let the Azure root server know which NVA instance is active or which one is passive. And finally, the final key sort of benefit I want to touch on is that the interface between the NVA and the Azure root server is based on the common standard protocol. So as long as your NVA supports BGP, you can pair it with the Azure root server. So just some limits that might be interesting and might help in the exam. So from the resource perspective, the number of BGP peers supported is limits 8. Number of routes each BGP peer can advertise to the Azure root server is 1,000. Finally, you have a limit of 4,000, which is a number of VMs in a VNet that Azure root server can support. So keep an eye out for these limits, because it could be something within the question that, especially the bigger scenario based questions that might come up. So keep an eye out for that. So moving on, just want to talk about identifying appropriate use cases for a virtual NAT gateway. So this is going to be final topic before I hand over to Mohammed Sajid to do the demo. So NAT gateway is recommended for all production workloads where you need to connect to a public endpoint over the internet. Outbound connectivity takes place right away upon the sort of deployment of the NAT gateway with a subnet and at least one public IP address. No additional routing configuration is required to start connecting outbound with the NAT gateway, which is really good. And finally, the NAT gateway becomes the default route to the internet after association to a subnet. NAT gateway load balancer and instance level public IPs are flow direct aware. So NAT gateway can coexist in the same virtual network as a load balancer and instance level public IPs to provide outbound and inbound connectivity seamlessly. Inbound traffic through your sort of load balancer or your instance level public IPs, they're translated separately from the outbound traffic through that NAT gateway. The sort of an NSG, network security group, allows you to filter inbound and outbound traffic to and from that virtual appliance. And what that does is you can then, to monitor outbound traffic flowing from a NAT, you can enable NSG flow logs then, you see. From a performance perspective, each sort of NAT gateway can provide up to 50 gigabits of throughput, which is quite a bit. And then this data throughput includes data processed both outbound and inbound through a NAT gateway resource. You can split your deployments into multiple subnets and assign each subnet or group of subnets a NAT gateway to scale out. So the NAT gateway can support up to 50,000 concurrent connections per public IP address to the same destination endpoint, which is quite good. And that's over internet to TCP or UDP protocol. The total number of connections that NAT gateway can support at any given time is up to 2 million, so that's quite a high number. And finally, NAT gateway process 1 million packets per second and scale up to 5 million packets per second as well. So, a lot of performance there. From a scalability perspective, scaling that gateway is primarily a function of managing that shared available SNAT port inventory. So NAT needs sufficient SNAT port inventory for expected peak outbound traffic flows for all your subnets that are attached to that NAT gateway. Finally, before we move on, so I'm going to stick with this topic. And specifically, you can port reuse timers determine the amount of time after a connection closes that source port is in hold before it can be reused to go to the same destination endpoint by that NAT gateway. Some sort of design considerations for configuring timers specifically. The first one is in an idle connection scenario, a NAT gateway holds on to SNAT ports until the connection idle times out. Because long idle timeouts, timers can unnecessarily increase that likelihood of SNAT port exhaustion. It isn't recommended to increase the TCP idle time duration to longer than the default time of 4 minutes, really. If a flow never goes idle, then it will not be impacted by the idle timer, so kind of no problem then. Specifically, TCP keeper lives can be used to provide pattern of refreshing long idle connections at endpoint liveness detection. TCP keeper lives appear as duplicate ACKs to those endpoints, and those are over low overhead and invisible to the application layer as well. Finally, UDP timers aren't configurable. UDP keeper lives should be used to ensure that the idle timeout value isn't reached and that the connection is maintained. So enough of me talking. I'm going to hand over to Mohammed Sajid and we're going to look at implementing a NAT gateway. So over to you, Saj.
Thank you, Shabazz. So we're just going to step through the process of creating a NAT gateway and look at its options. So to deploy NAT gateway, search for NAT gateway in the search bar and select NAT gateways. As you can see, there's nothing deployed at this moment in time, so select create to create your first NAT gateway. In our demo, we're going to deploy everything to our Am IT Geek subscription, and we're going to deploy into our AZ700 test resource group. And for the name, give it a decent name, so AZ700, AZ700, NAT gateway 01. Deployed in the UK South region. By default, everything gets deployed into this no zone configuration. Microsoft picks a zone for you, but you can deploy it into a specific zone if you want to zone 1, 2, and 3. For the demo, we will leave it at the default. And you have this TCP idle timer in minutes. So as you can see, it's default 4 minutes, and you can configure between 4 and 120 minutes. Again, we'll leave that as default. Select next. On the outbound IP address, you have the option to configure public IP address. Select one that already exists to create a new one, or create public IP address, prefix create a new one, or select an existing one. let's see if we can create. So we have one that's already available, NAT gateway public IP address. So we're going to select this one. We won't configure a public IP address prefix at this moment in time. If you're wondering what IP address prefix is, look at the earlier videos in the series where we go through creating a public IP address prefixes. Select next. And in the subnet, you need to associate the gateway with the subnet for it to be functional. So we're going to associate this with our VNet 02 AZ700 demo subnet. Select next. We're not using any tags in this demo environment, so we're going to leave that blank. But if you are using tags in your environment, you can configure them here. Select next to review and create. And once you're happy, after you reviewed everything you've configured, select create. This takes just a few moments to deploy, so if you just wait for a minute, you will see that deployment in progress, and you can select that, and it takes you to what's being deployed at this moment in time. So if we just hang on for just a few moments, this should be deployed, and we can take a quick look at it. If it takes too long, we'll look at it in the following video. There we go. That wasn't too long. So if we go to resource, you can see we now have a NAT gateway deployed. AZ700 NAT gateway, and that's the overview. So that's the name that we gave it. Though that's a virtual network that is associated with resource group AZ700 test resource group. It's in the UK South region, and it's part of the Am IT Geek subscription. And that's the name that we gave it, the AZ700 NAT gateway 01. Thank you for watching. Back to you, Shabazz.
Thanks, Saj. Another great demo this time around implementing that NAT gateway. And that brings us to an end to the designing and implementing cross VNet connectivity topics. So there have been 3 really informative episodes. I hope you found them informative anyway. Thank you again for everyone's ongoing support. We're going to finish off module 2 with the monitoring networks. So that'll be a single episode, so keep an eye out for when that drops. Please do leave any comments in the video, if you know any feedback. You can see mine and Saj's socials there if you want to tweet us or connect with us on LinkedIn or Twitter. As I said, the labs that Saj is doing, please do follow them yourself as well. Very important for your preparation. You can see the labs in the description, the link to the GitHub labs anyway in the description below. Thank you everybody for watching. Please do comment, like and subscribe. I can't emphasize that enough. Please do subscribe. Yeah, thank you for watching. Up until next time, goodbye.